and technical support guy. He's got the laptop that has the horsepower to render point clouds for us in a time-efficient manner. So, actually, you want to flip to the next slide here. So, point clouds. Who in here has worked with point clouds? All right, good. What kind of data source do you have? Do you get point cloud or
LiDAR?
LiDAR, airborne?
Long time ago, yes.
Long time ago. Have you used any other? No.
No.
Have you used anything else besides airborne LiDAR?
90%.
90%. Okay. So obviously we usually think about point clouds coming from airborne LiDAR. Dave's here, and Adam couldn't get me a picture of your setup in time, so I used the next closest thing. So typically what we see here with point clouds that's from airborne LiDAR is it's going to be pretty low to medium detail. It's going to give you really good topographic coverage, but it's not going to give you, we wouldn't be able to get, a solid like curb line or, thinking of a good example, like, you wouldn't be able to identify specific items in there. You're really just getting basically an X, Y, and Z value, right? So, obviously, when you talk airborne, we kind of there's a different, spec. But your USGS quality level 1 is 8 points per square meter. From there, it keeps going up. So quality level 2 is actually like 4, I believe. 2, okay. So it gets progressively worse. So 1 is the best. And then when you're doing high-res topo, which you would probably have here in the Muni, you're looking at about 20 points per square meter, I'm guessing. So the strength of airborne acquisition is that you can do large areas quickly. The drawbacks is that you are going to have a first return, last return. You're going to be pretty sure of what it is, obviously the tree cover or the ground. And then you have a lack of RGB value. And so flip on to the next screen here. This is actually Aaron, who just left, sent me this because I didn't have anything good. But this is obviously, this is Old Seward, 40th, 36th, Denali going up there. But this is, a LiDAR data set that's been colorized using the orthophoto. So pretty big area, large area. Next one. And then the next one, of course, is going to be where we get the these are the newer methods that I'm going to jump into here. I'm going to try to pick up a little bit of time. But obviously you have on UAS or drones, this is becoming very popular. To go buy a drone, I bought a DJI Spark at Best Buy for $600. I control it with my smartphone, and I can go out and develop a point cloud using Pix4D software, using that $600 drone. So it's really readily accessible. The big problem with it is that you're using photogrammetry to derive the point cloud. You're really just taking a series of photos. They basically get stitched together more or less with pixel matching algorithms, and you basically get a orthorectified is a dangerous word, but you kind of get an orthorectified composite image where every single pixel ends up getting an X, Y, and Z value similar to that. So the great thing about these is that you can actually get a point cloud using a UAS and a software, and you can combine direct vertical nadir measurement that you would like from an aircraft and also oblique. You can actually develop full 3D models. The drawback is it is what you see is what you get. So, I've been dealing with drones for quite a while. Actually, you want to flip the next photo there. I actually captured this. This is a well pad in northern Alberta. This is a 5-year-old data set that I captured 5 years ago. And the big thing with drones, people are like, oh, my drone can get point clouds. And it's like, no, it's your software. But if you don't do it properly, there's a lot of things, basically a lot of things can go wrong with drones if you're not careful in terms of data sets. So this is a very high resolution, very tightly spacing. These are 2.5 centimeter pixel on this. So next one. And then of course the newer technologies. This is a mobile LiDAR unit. Actually you want to jump back one. So what you have here is a dual-headed LiDAR system. Somewhat similar to what's on an aircraft, a little bit lower grade. You have two GPS receivers at a fixed distance, and then you have basically the main unit, which has an IMU inside of it. So you can basically drive around and capture ground level data sets on a vehicle. Not shown on here is actually a 360-degree camera that correlates with the scan data. So this is becoming a really popular, easy option that gives you great street level detail. So we can jump ahead. So when we start talking about terrestrial, we're going to talk about it a little bit differently. But you basically have about 2 centimeter pixel resolution, or 2 centimeter resolution at 20 meters away. So that's going to be your typical corridor width. And then there is a speed variable when capturing this. Again, it's actually, if you want to jump onto the next one here. So we scanned 4th Avenue back in July. We did about 6 blocks down there in about 10 minutes. And we have millions upon millions of points in very good detail. So that's the great thing about mobile LiDAR is you can capture this massive amount of medium to high detail scans in a short amount of time. So next one. And then now we're also introducing terrestrial scanning. This is really that's one of our units, that's the SX10. It's a scanner, a total station, and a high resolution imaging instrument essentially in one. With high detail terrestrial laser scanning, ML&P does a ton of this, so I'm gonna give, if anybody hasn't seen ML&P's scanning program, Aaron left because he had to go to a meeting, but he is the guy to talk to, I would say, when it comes down to the MOA and who's the guy that knows point clouds. It's too bad he had to leave. But with terrestrial scanning, you're gonna get very high detail, less than like 5 millimeters per pixel. But anyway, jumping ahead here, this is actually Kennecott Mine. It doesn't show up great in the PowerPoint, but we'll throw it open, the data set open here. So the big thing is we can get point clouds now at varying degrees of resolution, and we can dump all of that into GIS and have a very rich user experience. Point clouds will give you the extra bit of detail that's always needed. The issues I see with discrete point positioning, which is you go out and you just get one shot, oh, this is a water valve, oh, this is a fire hydrant, oh, this is a junction box, is you know where that is, but you generally, knowing where it is, X, Y, and Z in our world, and maybe some attributes about it, how does that relate to other things? And pretty soon after a while, you end up having to do a full survey to know how these objects relate to actual other physical objects, to a level of detail that's used for, you know, clearances, engineering, design, and that sort of thing. So if you want to jump ahead here, we'll jump into some eye candy here quick. Got 5 minutes left.
No, you're good.
We're good. All right. So so this is our 4th Ave data set here that we captured with mobile LiDAR and terrestrial scanning. We did it because we could. Who knows Charlie Barnwell? All right, so we captured this specifically to troll Charlie because he had a project down here in this location, so we drove it and said, oh look, we can do this really quick, and and then I tried to sell this to him for a lot of money. So this is a 10-minute scan. We drove both ways, and as you can see, we have just a ton of street level detail in terms of the topography, the heights of things, conditions. It's a little bit grainy. One of the things is actually, if you can see here, there's kind of like this thatching. That's actually from the dual-headed LiDAR system going. So you do get small data gaps, but you still get great coverage on your subject area. So I wouldn't try to, oh, there we go, that's much better. So if you can think about taking a data set like this and then overlaying discrete points of, you know, maybe there's a fire, it's not gonna show up great, but, and then there's a lot of cars down there. This was the middle of July, so it was busy in downtown. If I was doing this as deliverable to a customer, I'd probably do it about 7 a.m. on a Saturday morning, or Sunday morning.
You have about a half day to gather this data.
Yeah. So anyway, you know, we have all this background data that's here. We can even go and take this, and actually you want to jump into the MX2 data, or the MX publisher there. So this is, if you take the 360-degree camera and then point clouds overlaid, this is actually a survey with an MX2 of the LA River. And as you can see, we've got the point cloud overlaid on top of imagery. So out of the imagery, what we can do is we can actually extract features with very precise and accurate X, Y, and Z values rather than go out and use a discrete point, like a single point with a mapping grade system or a survey grade system. So that's pretty wonderful. And yeah, and then this is just a publisher software where it's actually, we could actually, I don't know if we can give it away, but this is actually a demo site that you can actually just access through a web browser, so you don't need special software. Anybody that's got Chrome and a solid computer can use this. So this is the mobile. I'm a big proponent of the mobile. I think we should scan everything, but that's just me. So let's see here. Do we want to actually? We'll go to iCanning now. Let's just jump over to Kennecott there quick. I'm trying to cut some stuff down to make some. Oh, actually, that's you can do this. This is our office building, so we did this with a high resolution. We did this with Eric actually did this with the SX10. So as you can see, if you want to zoom in on stuff, you can see the amount of detail. I mean, you can almost get the bolt pattern and bolt rolls off of these fire hydrants.
That's on course.
And this is on course as well. We can actually scan this at a higher detail. The unit we use, the SX10, has 4 different levels of scan. This is the lowest resolution of scan, so we could get much more detail. But as you can see here, between combining, with terrestrial scanning, we can get a lot of information out of here, not just in a design sense, but also in terms of geographic information. If we want to know if a vault's recessed or something's too low or too high, or we have those spatial relationships. So, and then of course everything works seamlessly because we're all in the same reference. Is you can actually, do you have your survey data in this project? So this all correlates directly with regular survey data. So, oh, there we go. There's some. There we go.
How long did it take to do that?
5 hours? What did you say?
Less than 5 hours.
Less than 5 hours.
Now, was it the mobile scan or the terrestrial?
No, that was the terrestrial scan.
And the benefit of this right here is really the fact that it's a total station and terrestrial scanner as well. There's no registration necessary at all. Everything comes in.
Right.
It's there.
Yeah.
And also grid or ground, however you want.
Yeah. Yeah, we can work in scale factors and that sort of with all this as well.
What's
so
the scan duration on that lowest setting?
What's that?
What's the duration for each scan?
Full dome in 15 minutes, but you can do selectable scanning, so you could actually just do a horizon, like just a panorama, and set the upper limit in like 7-8 minutes.
8 minutes for horizontal.
8 minutes for a horizontal band. So, yeah, there's a lot of things happening with point cloud. I'll kind of touch on that when we wrap it up, but there's a lot of things that have changed with point clouds. 10 years ago, if you came to me and said, I need this level of detail, I'd say that's going to cost you $100,000 to capture. Now it's like, we can do that for $10,000. There's the price and the processes and the cost of the technology have just shrunk dramatically in the past decade. So this is Kennecott Mine. I scanned this at the end of August. There was a whole army of us, but there's really only 2 of us that did all the work, as I'm going to say. But we actually did all this in about 2 days. So this is a huge historical landmark. There's an extreme amount of detail, but in 2 days, and you could get something. This was all done with terrestrial scanners. I just like to show this because it looks really nice, and everybody kind of, it's one of those great things. So we basically scanned the entire National Historic Landmark, the mill site, in 2 days with this. So we've got great detail. And what the folks there actually using this for is we're going to get away. It's one of those things where everybody got to the end of the year and we're all trying to get caught up from the busy summer. But we are going to look at putting distributing this in the GIS system at the Park Service, and making it accessible to people, because the one thing was just some out of the box applications we came up with on this data set was that there were people that were there and like, oh, it'd be great if I had this, because when we have to order in glass to replace these windows because they're trying to repair the old mill building, we'll be able to go, instead of getting up on a scaffold and climbing up and just about dying to go take a measurement, we can just use this point cloud and just measure take a measurement within the software, and boom, we can get glass shipped out to McCarthy, which is no small feat. So there's just having point cloud data is tagging on like they're telling us to. Is that the point cloud rendering engine is very clunky. It does a lot of caching. They really need to invest in having a point cloud engine that works well. It's serviceable, and then as you can see, everything is you can't quite tell on the projector, everything's a circle, like a dot, like a spot, and we need to be able to see them in squares, like a true pixel that they are. So, but besides that, you can totally take this high resolution data and literally just drag it into, he's under the GIS processing tab, but you can basically just add that into ArcGIS with a pretty simple click. You just add it to your project folder and then literally import it, and then
spots.
Yeah, there's some dots right there from a near object. But you can dump this in, create scenes really easily. And the only thing that I'd hunt around for was it was on an intensity based by default when you imported it, and it took me about 3 or 4 minutes to hunt around and find it where I could switch it to the RGB values. And I could probably help you hunt that down as well in the future, so give me a call. But it took a little bit of time, but it's totally possible to bring it into GIS very seamlessly. And the great thing about this data is extremely high quality. I would say an absolute accuracy, 2 centimeters, I think we had on this. So it's geo-referenced accurately. The measurements from the LiDAR sensor are 1 millimeter plus 1 parts per million. So this is extremely high accurate data, and you would have no problem designing off of this.
This is merging. Correct.
Oh, merging. So the 4th Ave Theater here, this data set's actually a merged data set between mobile LiDAR, which was pretty much that medium high detail with the hatching and wide, and then we scanned the front of the 4th Avenue Theater with it was on standard, right?
That was on standard.
It was on standard, so we went through and did a finer, refined scan on it, and then we merged those 2 data sets seamlessly. So, I'd love to have a LiDAR data set of this same area and basically just plunk that in and just watch, we'll be able to get the tops of the buildings. So that's kind of it. You want to flip back to the PowerPoint? I'll just show what Aaron and the guys at MLP have been doing, because this is, so Aaron, who walked out of here because he had to go to another meeting, is the guy to talk to here. But they're doing basically a lot of their as-builting and engineering design using scan data. And as you can see here, these are just open trenches. And it looks like a picture, but it's not. This is laser scanned. And just the amount of detail for documentation is insane. But not only that, because it's geo-referenced, they can just dump that in anywhere. And so if they had to go back and design something in that same location, he's got a pretty decent system for a repository of this, right? He's told me about it, I've never seen it, but he basically has laser scan data all over the city that is basically archived by location. So this can be used on future projects. So that's huge. There's the plant, this is a substation, and then the next one is an underground vault. So again, Aaron, if you work for the Muni, Aaron's the guy to talk to. It's really quite incredible. Go to his office down there off of, kind of down by the railroad there.
First and Post.
Yeah, First and Post. You guys work there. So go down there, get him to bring it up on his giant TV in his office, and just watch in shock and awe. I take people there that I kind of know and be like, oh, you should check this out. So it's awesome. Okay. I'm only 5 minutes over after starting 10 minutes late, so I really appreciate your time. Does anybody have any questions? I know we're rushed through it, but we want to get our service members in here to talk about GIS at JBear. So, any questions?
What kind of file sizes are you talking about in storage?
Oh.
It's going to be cheap, but not necessarily tall.
Yeah. Kennecott's what about a gig?
It's more than that. When you include everything, it has not been cleaned. This is the full data set. Total is around 8 gigs, I think, without anything.
Right. Yeah.
We're talking
So if you were to do the whole city like a mobile LiDAR, you probably Fourth Ave, what? I want to say it's like 1.6 kilobytes. We actually have the LAS file here. We can tell you how big it is.
That's 8.5 million.
Yeah, there's 8.5 million points.
Again, that's not been excessively clean. This is a test run right here.
Yeah. I would say that you're probably looking at file size, maybe a gigabyte. So, and that's 6 city blocks, but yeah, you multiply it out, it does look like a lot, but the big thing is though is with everything going into the cloud now and I feel like data storage is a challenge, data transfer is the biggest challenge, but I feel like 5, 10 years down the road, we won't even remember those days, right? So, any other questions? Yes,
I was curious on the mobile LiDAR, actually the terrestrial too. So with airborne, we're focused a lot on our Z and our accuracy.
Yep.
We throw X and Y out the window because we know it's rough. So you guys are kind of focusing more on that X and Y a little bit. And how do you deal with that and beam divergence? I know it's a real short baseline, but have you guys been able to calculate how that affects your accuracy?
What's that, beam divergence?
Right, yeah.
Spot size? Yeah. Derek's got it.
I play around with doing because aerial data. You're going to do QC with it with usually with traditional survey method. A lot of times I'm using this is just use a total station multiple shots, checking how old it's tolerance. Beam divergence. I came up with the specs on Linux too. We don't have a real mapping expert here.
Yeah, he's in Minnesota, but I mean, I couldn't say, at 20 meters. I mean, that's kind of what you're going to look for in terms of an optimal when you're doing corridor mapping.
I want to say the beam was, I think it got up to around like 8 millimeters, 10 millimeters at like 100 meters, something like
Yeah.
that.
So yeah, I guess it depends on the diameter of your aperture. So
Yeah.
if 20 meters, yeah, I guess it really depends, but it could be up to 6 millimeters and 20 meters.
Yeah, it's not. I mean, it's not huge. I mean, that's the big thing is different sensors for different applications. So yeah.
Yeah, they typically most of the quarters they drive with these things are around no more than 200 feet, and that's at most. And theoretically, it can get returns out to 250 meters, I believe. It's not.
Well, actually, you get some beyond that, but accurately, 250 meters is a spec. But it's yeah. I mean, when you're focused at that, even on a downtown, like on that 4th Ave, I mean, we drove it both ways, so it's one of those things where, it's very repeatable, but when it comes to this application, yeah.